What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram, drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best.
Alright, so okay, welcome back, my NextGen family. We are gonna go through the next paper for today. October-November 2024, paper 1-2. Okay, we're gonna do the first half of the paper first. Okay, so we're gonna practice it without calculator. Okay, we try our best to do as much as we can without a calculator. We see whether it's possible to do or not. Okay, because right now, all your papers, I want you all to try to do at least the first half without calculator if possible, so that you'll get enough practice for your new format of the paper. Okay, let's look at question 1. Okay, can do without calculator. The curve y equals to a cos bx plus c, where a, b, and c are integers, passes through the point negative pi over 6, negative 2, and pi over 9, 1 over 2. The curve has a period of 2 pi over 3. Okay, find a, b, and c. All right, which value do we start with first? A, B, and C. Okay, which one do we start with first? Okay, so I just write here first, A cos bx plus C. Okay, we just need to be clear. A refers to your amplitude. B is the period. C is your vertical translation. Okay, very good, Aurelia. Okay, we will start with B first because period, okay, period is equals to 2 pi over b, or 360 degrees over b. Okay, so you got to start with the b value first. Period equals to 2 pi over b. Okay, what's the period? Okay, period here is equals to 2 pi over 3 equals to 2 pi over b. Okay, we rearrange it. B equals to 2 pi over 2 pi times 3. Okay, or divide by 2 pi over 3. Therefore, b is equals to 3. This is your first value. Okay, now we have this b already. Therefore, our equation will be y equals to a cos 3x plus c. Okay, this will be the first answer. Okay, we got two values that they gave us. Negative pi over 6 and negative 2. Okay, let's just sub it inside. Negative pi over 6. Okay, what will we get over here? Okay, maybe I write it here first. A cos 3x plus c. Or maybe, sorry. Okay, I'm going to substitute here. Negative pi over 6, negative 2. So x is equals to negative pi over 6. Y is equals to negative 2, which we'll get minus 2 equals to a cos 3 negative pi over 6 plus c, which will get a cos negative pi over 2 plus c. Okay, can we do this without a calculator? Cos negative pi over 2. Can, right? Okay, what's pi over 2? Pi over 2 is 90 degrees. So can we find negative 90 degrees? This one can. Okay, you use your graph. So if you don't have a calculator, or this comes out in paper 1, which I think is a possible question for paper 1, you can use like this. Like this, okay? So negative pi over 2 will be here. Okay, which is equals to 0. So a times 0 plus c. Okay, therefore c is equals to negative 2. Got it? Okay, so for any intervals of 90 degrees, you all use the graph. Any in the special angles one, which is your 30 degrees, 45 degrees, and 60 degrees, you got to use the special angle from the triangles. Okay, so let's look at the second point. Pi over 9 and 1 over 2. We substitute. Okay, we will get here 1 over 2 equals to A cos 3 pi over 9 plus C. Okay, we already got the C value, so this one is minus 2. Okay, what will we get over here? Okay, let's see. Okay, we bring the minus 2 to the left-hand side first, so this will become 5 over 2 equals to A cos pi over 3. Okay, pi over 3, can count or not? Okay, so you all need to know how to do this without a calculator. Okay, can y'all do this? Okay, what's pi over 3 first? Cos 60, right? Okay, cos cos 60. Okay, how do we find cos 60? You use this triangle. Okay, just in case you all forget already, use a equilateral triangle with sides 2. You split it into half, like this. Okay, I know some of you all can memorize all the values, but majority of you here, maybe you all don't memorize it. So you all just use a triangle. So here will be 60 degrees. Cos is ka. So here will be sec 3. Okay, so this will be the triangle that you use. 2, 1, and sec 3. Here 60 degrees, here 30 degrees. So ka will be A over H. A over H, which is 1 over 2. A bracket 1 over 2. Got it? Therefore, A is equals to 5. So we got these 3 values. And I did it all without a calculator. Y equals to 5 cos 3x minus 2. Okay, good. Okay, so does that mean we have to memorize all the special angles? Yes. Yes, if it comes out in paper 1, because you all don't have a calculator. So what are special angles that you all need to know? 30 degrees, 45 degrees, 60 degrees. Okay. How do we get 1 over 2? We use SOHCAHTOA. We use SOHCAHTOA according to this equilateral triangle. So for you to find your sine, cos, and tangent for 30 degrees and 60 degrees, you're going to use an equilateral triangle that has sides 2. Okay, this one you have to memorize it. Okay, an equilateral triangle that has sides 2, because then after that we chop it into half. Okay, we split it up into half. Why split into half? Because you split into half, here got 60 degrees, here got 30 degrees, and then we can use a 90 degrees angle. Can see or not, Jordan? So here, you see, cos, we are trying to find cos 60 degrees over here. So adjacent over hypotenuse, according to this triangle here. Okay. If not mistaken, you all go to the paper 1-1. Okay, I explain it quite in detail, these 3 angles. Okay, you all just go to this series, paper 1-1 or 2-1. I think if it's not mistaken, it's paper 1-1. So you all go and look at how I explain related to the triangle here. Okay, any other question? Yeah, go and figure out this part here. Okay, your special angles. Okay, let's look at question B. Find the least value of y on the curve from 0 to pi over 2 and state the value of x at which this occurs. Okay, let me see. Can we do this without calculator? Okay, actually can. Okay, first thing, how do we find the least value? Okay, the least value for this question here. Okay, what is the least value of a cos graph? So that's the first thing we need to determine. So we can straight away, okay, if you understand this question, so your equation is this y equals to 5 cos 3x minus 2. A typical cos graph, the least value is when this cos is negative 1. Right or not? Okay, you all have to see, based on your original cos graph, okay, is that 1? Is that negative 1? Okay, so here, originally, it is pi. So now, we just take cos 3x equals to negative 1. Because this is based on cos x itself. we take cos 3x equals to -1. Then 3x is equals to inverse cos -1. Okay, where is it -1? When you inverse, it is at pi. Therefore, 3x is equal to pi, x is equals to pi over 3. Okay, this will be our working. And then, from here, how do we get the y value? They say, state the value of x at which this occurs. Find the least value, and then find the least value of y. Okay, to find the least value of y, you can just do like that. 5 cos 3 pi over 3 minus 2. Okay, this part here will be equals to -1. Okay, why is it cos 3x equal to -1? Because the minimum value occurs at y equals to -1. This value is equals to -1, according to the graph. You see it? Okay, so here you substitute. Okay, this one will be 5 times -1 minus 2, which will be equals to -7. Okay, number 1. If you understand this, can you type 1 in the chat? Okay, don't understand? Ask all your questions. Okay, please ask all you can. Okay, 1, 1, 1, 1. I see all the ones. Okay, let's move on to number 2. Okay, just now you say do not do number 2. Okay, 2a. It is given y equals to fx, where fx equals to 2x minus 5x minus 1 square. Find the coordinates of the stationary points on the curve y equals to fx. Keyword, coordinate of stationary points. Okay, what is coordinate of stationary points? dy over dx equals to 0, right? Because gradient is equal to 0 at here. Okay, in this case, they put it in fx. So we want to find f prime x equals to 0. Okay, so we need to differentiate this. What rule do we use? 2x minus 5, x minus 1 square. We can use product. Okay, this one is a product rule. U equals to 2x minus 5. V equals to x minus 1 square. U prime is 2. V prime, 2 bracket x minus 1. Then you cross it. Formula f prime x will be u v prime plus vu prime, which will get 2x minus 5 times 2x minus 1 plus, okay, this one I rearrange it, just put the 2 in front, 2 bracket x minus 1 square. Okay, we can open up the bracket. Okay, this will be 2x minus 5, 2x minus 2 plus 2x square minus 2x plus 1. Okay, then cross multiply, open up the bracket. 4x square minus 4x minus 10x plus 10 plus 2x square minus 4x plus 2. Okay, join all the values with each other. We will get here 6x squared, x minus 4 minus 10 minus 4 minus 18x, then plus 12. Okay, we also want to make it f prime x equals to 0. Okay, so f prime x equals to 0 here. So here become 6x squared minus 18x plus 12 equals to 0. We divide the whole thing by 6, which will get x squared minus 3x plus 2 equals to 0. Factorize this, we'll get x minus 1, x minus 2 equals to 0. Okay, where we'll get here x equals to 1 and x equals to 2. Okay, all right, like this, okay, because we want to get the y value also. So y will be equals to 2 times 1. So 2 minus 5, 1 minus 1 square, which is equal to 0. Okay, so the stationary point for this is 1, 0. The other one, 2 times 2, 4 minus 5, 2 minus 1 square, which will get minus 1. So the coordinate here will be 2 minus 1. Okay? Clear on this? Okay, just now someone said don't know how to do, right? Okay, are you okay? All right, now we need to sketch this out. How do we sketch this question? What graph is this? 2x minus 5 bracket x minus 1 square. Okay, what graph is this? Quadratic. Are you sure quadratic? You got one bracket, then you got a square. Cubic. Okay, this is a cubic graph with an equal root. Do you remember what's equal root? Okay, a cubic graph. One of it is the root, then the other one is an equal root. So we need to be clear over here. 2x minus 5, x minus 1 square. Okay, don't need to go open up the bracket. Okay, so we will start by writing the SIM. Okay, what's SIM method? Design teacher's acronym for any graph. We first need to determine what's the shape, what are the intercepts, then what is the maximum or minimum point. Okay, so shape. How does the shape look like? Okay, the shape of the graph. Sad, happy. Right or not? Sad then happy. Because our ax cube value is positive. Okay, ax cube is positive. So you will sad, happy. You suffer now, enjoy later. So you'll end with a happy life. Second one, intercept. Okay, do we have the intercept calculation from the top? Okay, so we need to find what is the x and y intercept. Okay, let's find this. Intercepts. Okay, we start with the x-intercept first. What will be the x-intercept when y is equal to 0? So you take these two, okay, these are the factors, then x will be equals to 5 over 2, okay, or 2.5. Then the other value will be equals to 1. X minus 1 equals to 0. Okay, we need to know that this is the equal root. Why is it equal root? Because there's a square at this factor here. Okay, equal root means that the graph will just touch. Okay, will just touch the graph only. So at 1, it will touch, then after that, it will reflect back to the other direction. Okay, what is the y-intercept? Y-intercept is when x equals to 0. So y equals to negative 5, negative 1 square, okay, which is equals to negative 5. Okay, so we need this value here, 2.5, x equals to 1, and y equals to negative 5. Okay, so these are the main points. We also can use this information here. These two are your turning points. You all see it? Because this is the stationary point. Okay, is it necessary to plot? Not necessary, but you can plot it out to answer the next question. Okay, there's a reason why they ask you to calculate this stationary point. Okay, so your maximum minimum point, M, max or minimum points, will be your stationary point, which is 1, 0 and 2, negative 1. Okay, 1, 0 and 2, negative 1. Okay. Okay, so SIM, you all see the acronym here. For any sort of graph, we use this as a guidance when we draw it out. Okay, now let's plot out all the values first. You need to write down the value. Okay, don't make the mistake of not writing down the value. So here we'll have, okay, just roughly estimate. So here will be 1, okay, 2, let's say 2.5 around here. Okay, so this is the x-intercept. Then we have y-intercept minus 5. Okay. Isn't y supposed to be negative 4? Minus 5 times 1 is times 1. I got plus 1. Okay. Then our graph is like this. Going up, going down, and going up. Right? So sad face, then happy face. Then you all look these two are your turning points, right? 1, 0, and 2, -1. Okay, so 2, you try your best to also draw as accurate as possible. 2, -1 should be nearer to the 2.5, but they're not so particular about this. Okay, so you don't go too low also, because -1 should be around here if I put the -5 here. So this will be our graph. Like this. Go up. Okay, this point here will be 2, -1. You don't need to plot it out, but you need this information for the next question. Okay, clear? Right. Question C. Hence, find the values of k for which fx equals to k has exactly one solution. Okay, what does it mean? Fx equals to k has exactly one solution. This means, what are the y equals to k? Okay, y equals to k value means a horizontal line. When we draw a horizontal line, where exactly will we get one answer? Okay, that means one point of intercept. So you look at the graph here. I'm going to draw a horizontal line here. Okay, over here and over here. So anything that is above this yellow line and anything that is below this yellow line, okay, will be one intercept. Because you see here, all one time only, right? Here also all one time only, right? Okay, so what would be this line called? We look at the y. Okay, so your k here, okay, this section here will be k. Okay, this is y equals to k. Sorry, k is equals to, sorry, y equals to -1. This one y equals to 0. So we want everything above here. Okay, so your answer will be k is more than 0. This part here is y more than 0. This part here is everything y less than -1. So k less than -1. Okay, these two will be your answer. K more than 0 and k less than -1. Okay, number 2. Please type 2 if you are okay. Got a question? Please write down your questions. Okay, see all the tools. Okay, 2. Okay, remember, no silly questions here. Ask all your questions that you want to ask. All right, let's go to number 3. Okay, still no calculator. Okay, this one we need calculator just for one part. Okay, the question A. So in this question, okay, all lengths are in cm and angles are in radians. The diagram shows a circle with center O and radius 12 and a circle with center C and radius 5. Okay, the circles intersect at point A and B such that OA and OB are tangents to the circle. Okay, why is it important to know this? Tangents to the circle. This goes to our circle theorem. Tangent means you'll form a 90 degrees over here. Okay, tangent to the radius. Tangent to the radius. Okay, show that the obtuse angle ACB is 2.35 radian, correct to 2 dp. Okay, this one you have to use calculator. So how do we find this ACB? We can use half of this triangle first. Okay, so let's draw it out. OAC. This is 12, 5. Okay, what does obtuse mean? More than 90 degrees. More than 90 degrees. Acute, then obtuse. Okay, in between 90 to 180. So we want to find this angle here. Okay, this theta. This time we use calculator. Theta, this will be opposite over adjacent. Therefore, it will be tangent angle ACO equals to 12/5. Okay, this one you all use calculator. Angle ACO will be inverse tangent 12/5. Convert your calculator to radian mode first. You should get 1.176. Okay, then angle ACB will be 2 times angle ACO. So 2 times 1.176, which is 2.352. Okay, rounding up will be 2.35 to 2 dp. Okay, the next one. So now we have here, which is, whole thing is 2.3 Okay, perimeter of the shaded region. We have here, okay, 12 and 12. The only thing that we need to find is this arc here. Okay, so formula of arc AB will be r theta. Okay, S equals to r theta. R is 5 times 2.35. Okay, 5 times 2.35 will be equals to 11.75. Okay, so I think onwards here, you should be able to do it without calculator. So if it comes out in paper 1, you'll practice this without calculator. Okay, then perimeter will be 12 plus 12 plus 11.75, which is equals to 35.75. Okay, the last one. Find the area of the shaded region. Okay, how can we find the area over here? We can take this shape, okay, which is a kite, and this kite is made up of two triangles, right angle triangles, minus the sector of this ACB. Okay, so we'll take area of kite minus area of sector. Okay, but the kite is equals to two right angle triangle. Okay, two triangles. So I will use 2 times half times base times height minus half r square theta. So here will become just base times height. Okay, what's the base times height value? The base is 5, the height is 12. Okay, 5 times 12 minus 1 over 2, 5 square. Theta is 2.35. Okay, 5 times 12 will be 60 minus 29.375, which will get 30.625. Okay, or 30.6. Yeah, I think this is quite easy. Okay, question 3. All good. Can you just type 3? Three is very good. All right. Okay, let's go to question 4. Okay, just now a few of you also not so sure how to do 4. Okay, function f. Fx is 4 ln 3x minus 2 for x more than a, where a is as small as possible. Okay, so this is a ln question. Write down the value of a. Okay, a is your domain. How do we find domain of ln? Logarithm and ln. Okay, this one you have to memorize it. You will take the argument more than argument is more than 0. Okay, that will be the answer. Okay, you take this one, your argument. Argument means whatever that's inside the bracket more than 0. This is how we get domain. So for this case, okay, we'll take 3x minus 2 equals to 0. X is equals to 2 over 3. Okay, but since x is more than a, so we'll say a is equals to 2 over 3. Okay, the next one. Write down the range of f. Okay, when we do exponential and ln question, we need to know exactly how does the graph look like. So you do a rough sketch out. What is the typical range for a ln graph? Okay, how does ln look like first? Like this, right? Okay, right now, we know that the domain is more than 2 over 3. Okay, that means here, okay, this part here is x equals to 2 over 3. This is your asymptote. So the range will be from negative infinity to positive infinity, which is all real numbers. Okay, we can write down the range. We can just write real numbers. Okay, this is real, or all real numbers, or just real numbers. Normally we will use that symbol. Okay, or you can write like this also. F is ER. Okay, the next one, let's find what is the inverse, then state the domain and the range. Okay, we'll always start with this statement. Let y equals to f inverse x, fy is equals to x. Okay, we get here 4 ln 3y minus 2 equals to x. Ln 3y minus 2 equals to x over 4. 3y minus 2, we inverse. Ln will be e to the power of x over 4. Okay, then here we will get y equals to e to the power of x over 4 plus 2 divided by 3. Okay, we can just write it as times 1 over 3. Then the final one, we just rewrite this, f inverse x equals to 1 over 3 e to the power of x over 4 plus 2. Okay, what is the domain? Domain will follow the range of f, which is all real numbers. So x, er. Range will be f inverse. Just now is x more than 2 over 3. Now this is f inverse more than 2 over 3. Okay, you're trying your best to follow the mark scheme. So yeah, some of you will ask me, teacher, can write y or not? Technically, it's not wrong, but we try our best to follow what the official mark scheme writes. Okay, the last one. Question 4. On the axis, sketch the graph of y equals to fx and f inverse x, stating its intercept with the axis. Okay, this is a 4-mark question. Okay, to be more accurate, this one, okay, will they ask us to draw out the asymptote? Okay, to be honest, the mark scheme actually got right, but I don't think if you don't, I think if you don't write it out, it should be okay also, as long as your graph is correct. Okay, but to be safe, right, if you know what's the answer, then you'll just draw it out. Okay, that's the safest side. Okay, when we draw inverse, normally what I want you all to do, what I'll do is, we will start by drawing your y equals to x line first. Okay, so we can draw a symmetrical graph with each other. Okay, so draw a y equals to x here. Okay, then you can draw this out also, okay, which is your two asymptotes here and here. Okay, you see, if you decide to draw the asymptote, you need to draw it correctly also. Okay, it needs to intersect nicely on the y equals to x line. Okay, what the asymptote is your domain and your range. Okay, so this is y equals to 2 over 3, x equals to 2 over 3. Okay, they never ask you to write it out, but then you all can draw it out to draw a more accurate graph. Okay, how do we draw the fx graph? Fx is a ln graph. So a ln graph looks like this. Okay, I want you all to normally, what you're going to do is you draw it like this. Okay, your asymptote here, you have to be careful. Draw almost like a straight line like this. Then like this. Okay, don't go beyond here. Okay, don't go to the next quadrant. And what we need to label is here equals to 1. Okay, here also draw symmetrical to it. Okay, here will be 1 also. Now we draw almost like a straight line. Like this. Okay, this will be your fx. This will be your f inverse x. Okay, 4. Ken, this graph, this is a 4-mark question. This has come up many times. Yes. Yes. Normally, if they ask you to draw ln graph for functions, normally they will ask you to draw the inverse graph. It's normally the same exact question. Okay, you all do enough past year question, you see this question come up many times already. Okay, let's go to question B. Given that gx equals to 2x plus 1, power 1 over 2 plus 4, x more than 0, and we want to solve for ggx equals to 9. Okay, let's find what is ggx first. ggx will be g 2x plus 1 over 2 plus 4. Okay, so now our new input is this. we replace our x with this. So 2 bracket 2x plus 1 power 1 over 4 plus 4. Correct. 2 then plus 1, the whole thing to the power of 1 over 2, then plus 4. Okay, this one had to be very careful. Okay, I also confused a little bit. Okay, then we just write straight away, right, equals to 9. Okay, let's solve for this question. Okay, bring the 4 over to the other side first. So here will be 2 bracket. Okay, hold on, let me just double check. Am I doing the correct bracket? 2x. X is this whole thing, right? Plus 1. Okay. Okay, we bring the 5 to the other side first. 2 bracket 2x plus 1 to the power of 1 over 2 plus 4. Okay, wait, we can open up this bracket. 2 and plus 8 plus 1. Okay. Open up this one here. Then equals to 5. Our 1 over 2. Okay, then here, 1 over 2, bring to the right hand side, will become square. So 2x plus 1 to the power of 1 over 2 plus 9, 5 square, which is equals to 25. 2x plus 1, 1 over 2 equals to 16. 16 divided by 2 will be equals to 8. 2x plus 1, 8 square will be 64. X will be 64 minus 1 divided by 2, which is equals to 63 over 2 or 31.5. Okay, number 4 is type 4 if you are okay with 4. See all the 4s in the chat? No question, huh? Okay, let's go to number 5. 5a. Show that 1 plus cotangent square theta over cot square theta equals to secant square theta. It's just a 1-mark question. Okay, on the left-hand side, let's split it up. 1 over cot square theta plus cot square over cot square theta. Okay, what is 1 over cot square theta? It will be tangent square theta plus 1. Every time when we do trigo with a square, I want you all to refer to your identities here. Okay, you get some clues from here. Bring it down here. Okay, which one can we use? Tangent square plus 1 is equals to sec square theta. Sure. Okay, B, write down the derivative of tangent theta with respect to theta. Okay, this literally just write down the answer only. Okay, when you differentiate tangent, you get secant square theta. Then using part A and B, find the exact value of this one. Integrate from 0 to pi over 3, 1 plus cot square theta over cot square theta minus sin theta d theta. Okay, we are going to replace this by sec square theta first, because that was proven in A. So integrate from 0 to pi over 3, sec square theta minus sin theta d theta. Okay, when we integrate secant square theta, 1 over cos square x is also secant square x. Yes. Yeah, it's the same thing. Okay, but we don't need to use the 1 over cos square x. But if you use, okay, maybe the first one, sometimes you may prove it to 1 over cos square x also can. Okay, there's other methods normally showing it. Okay, from here, secant square theta, when we integrate secant square, we'll get tangent. So tangent theta minus sine will be what? we use the acronym SC negative S negative C. Okay, negative sign, you go up, will become positive cos. So positive cos theta from 0 to pi over 3. Okay, this part here, you can do it without calculator. So it's a possible paper 1 question. You sub in the values, tangent pi over 3 plus cos pi over 3 minus tangent 0 plus cos 0. Okay, pi over 3, we will refer to the special angle triangle. Okay, draw it out first. This is a 60 degrees equilateral triangle. Then you split it into half over here. Okay, pi over 3, we are just going to use the 60 degrees here. 60 degrees. Here is 1. Then using Pythagoras, this is sub 3. Okay, what is tangent pi over 3? Okay, tangent 60 degrees. Towa. Okay, what's towa? Sub 3 over 1. Okay, or sub 3. Then cos 60 degrees or cos pi over 3, ha, 1 over 2. Okay, so learn how to draw this triangle. So if they happen to ask you sine, so sub 3 over 2. Okay, then here, okay, we write down the value here, sub 3 plus 1 over 2. Okay, tangent 0 and cos 0. So this will be 0, cos 0 will be 1. This is according to our graph. When you see intervals of 90 and 0, you just base it on your original graph. Okay, this is your tangent. So tangent 0 is equal to 0. Then cos 0, we will follow this graph. Here. Cos 0 equals to 1. Okay, go add it up. So sub 3 plus 1 over 2 minus 1, we'll get minus 1 over 2. Good. Okay, until here, number 5. Please type 5 in chat. Okay, can I scroll back to 5A? Yeah. Okay, 5A, maybe some of you use, did any one of you get secant? Okay, so you can change your cotangent. Yeah, y'all can change your cotangent square, or yeah, y'all can change the 1 plus cot square also can, right? Because you see 1 plus cot square is also cosecant square. So maybe some of you change the top part to cosecant square over cotangent square, also it works. Alright, okay, we'll pause here first. Okay, for this first half of the paper, I think it's quite easy. Okay, question 1 to question 5. The hard questions are in the second half. Okay, we'll see you in the next one.